So let's talk about hypothesis testing. This is your chapter 8. So first thing, what are the steps of hypothesis testing? Step 1 is writing the hypothesis. So there are two types of hypothesis. One is null. Another is alternative. From a statement in the problem, we form the alternative first. So how many different choices are for the alternative? Because the null hypothesis is always a population mean equal to a constant number that is given in the problem. So this is the population mean mu. And the alternative will be, there are three different choices. So I'm denoting this constant value at mu 0. This is a constant value that's given in the problem. Alternative will be three different types depending on what is asking in the problem. Number one is mu less than mu 0. That's a possibility. Mu greater than mu 0. That's second possibility. And third is mu not equal to mu 0. These two are called one-tailed test. And the last one is called two-tailed. So it's given in the problem that how this is, for example, so one of them will be given to you in the problem. For example, in your 8.1 example, in page 360, they're talking about mean response time. So in that problem, the mean response times mu, that is equal to 1.2 seconds. And the alternative is not equal to 1.2 seconds. So this is a two-tailed test that they're performing. But I can change this if I make a statement like this. So this is given in the book, but that can be different if I make a statement like the mean response time is less than 1.2 that we want to test. In that situation, HA will be mu less than 1.2. So this is where the change comes from. This will be then case number 1. So that is the difference. So there are three different possibilities, one at a time, for a particular question that I'm going to ask. This is in your book. The example is for the third one, two-tailed test. Now, where that's going to affect in R, if we are using R, where is that going to affect? I'm going to show you that. But before that, this is the general description of what would be the step 1. This is the step 1. So in your example, this is the step 1 that they're writing. This is the step 1. That's what you're testing. The same number, the null is 1.2, alternative not equal to 1.2. But that could be less than or greater than, depending on what information I'm giving in the problem. But that is always a statement in the problem about the alternative. So that's what you are looking for. So this is step 1. In step 2, now in step 2, we are deciding about what test we need to do. So step 2 is more about deciding what test. And what are the tests? This is the first, what we're going to learn is the test for mean. And that would be for one sample, just one column of data given to you, and we are looking for the test for the mean for one sample. Question is what are the two different tests there is? One is for large sample. Typically that means for this class n is bigger than 30. Another is for small sample. For this class, this means n less than 30. So greater than or equal to 30, and this n less than 30. That's the setup. Now for this one we use a z-test, and for this one we use a t-test. So there's a z-test, there's a t-test, that's the difference. Now again, we are not going to do this by hand like the book is doing all the calculation by hand, but we will use R. So let's talk about the z-test here first. And I'm going to post a PDF file where the z-test will be, how to do the z-test, that will be a R code that I'm going to post, but I'm writing it here anyway. So what you need to do for the z-test, from your step 0, you know whether it's less than or greater than or not equal to. So in the z-test, you have to put the data first, which means your one column of data, and then you have to write down what would be the standard deviation is. What is the value of the standard deviation? Because that is, for n bigger than or equal to 30, you should know. So this is known sigma. You should know the standard deviation. So you have to put it in there. Also, how do you decide it's a one-sided or two-sided test? That will be under the alternative. You have to put it under the alternative whether it's greater, or there will be a choice less, or there will be a choice like two-sided. So those are the choices for the alternative that you need to put it in, depending on which one you are using. And also, if you're testing for a mean, whatever the mean is, you can put that too, the mu equal to whatever that number is, because in this case mu is 1.2. So all this will go into the z.test, and that will give you what we call a p-value. So you will get an output, and then output will contain a p-value. The p-value, that's what we are looking for. So that's the p-value. We're going to decide from the p-value whether to accept or to reject the hypothesis. Now the rule of thumb is, the ROT rule of thumb is, your p-value, if this is less than or equal to alpha, you reject H naught. If it's greater than alpha, fail to reject. Fail to reject H naught. So that is the whole deal here. Now what is alpha? Alpha is by default 0.05. If nothing is said about the alpha, that will be 0.05, so you're comparing 0.05. Otherwise it will be given to you if it's different. If it's different than 0.05. So default is 0.05, but if it's different, then it'll be given in the problem. So that's pretty much what the structure is for the z-test. When you do the z-test, it's known sigma or n bigger than or equal to 30, then you are doing this. Similarly, there is a t-test for the small sample. So number 2, for the small sample, and again, I'm gonna give you the code in the PDF document, but the code look like it's a t-test It's the same idea. You put the data in, and then you have the alternative depending on which one you want. So maybe it's a less than, then you type less, or it's a greater, you type greater, or two-sided. Now you can put it mu equal to, just like before, for another example, or whatever the mu is, you can put it in like that. And that's pretty much what you need to do. And again, you will get a p-value. And then you compare with 0.05. So that's pretty much the structure for the small sample. So for the example 8.1, the step 1 that I wrote before, mu equal to 80 is mu equal to 1.2 versus the alternative mu not equal to 1.2. It's in page 360. Now, step 2 will be doing a z-test, because n is 100, which is bigger than 30. So since n is 100, which is bigger than 30, I'll do a z-test. And then if you do the z.test, whatever the data is, here data is the given to you 100 responses. So that's the data, you plug it in here. Your mu is equal to 1.2. Your SD, which is the sigma, that's, they already calculated that, 0.5, so on. And the alternative, by default, the alternative is two-sided, so you don't have to put the alternative here, but you can write two-sided. And then finally you get a p-value. So once you get the p-value, you compare that with 0.05. If it's less than, then you reject. If it's greater than, you fail to reject. So that's pretty much the idea. Now what's going to change if this is a t-test? So let's talk about another example. Example 8.3, the same data set but different numbers. Page 367. So we are testing the same thing. The step 1 will not change. 80 mu equal to 1.2, HA mu not equal to 1.2. And here they're actually coming up with the p-value, I'm guessing. In 8.3, they have the p-value of 0.0026. So you can now decide, since this is less than 0.05, you reject H naught. So that's not the t-test, that's they're just giving the p-value here. But this is the t-test example that I'm doing right now. And I think in your book, the t-test example is in uh, 8.5, example 8.5 in page 374. And the hypothesis there, mu equal to 20 versus the alternative is mu less than 20. And the alpha is given as 0.01, meaning this is the one that you compare with the p-value. So now you run the t-dot test. So this is your step 1. In your step 2, you're running the t-dot test with the data, and mu equal to 20. Alternative equal to less, because the alternative is less here. And that should give you again a p-value. And compare the p-value. If this is less than equal to 0.01, then you reject. If it's greater than 0.01, then you fail to reject H0. Then you fail to reject. So that is the concept. And the p-value they got is, so p-value that you will get from the R is 0.014. It's 0.014. Which is bigger than 0.01, so you fail to reject the null hypothesis, meaning that this is actually true. Mu equal to 20 is possibly that is true. So that's pretty much the difference between the z-test and t-test. Now the question is why this is a t-test. That depends on n. What's your n here? N for this particular example is 10, which is less than 30. So that's the reason that I decided to do a t-test, and this is the reason here, n equal to 100. That's the reason I decided to do the z-test. But this is always one sample test for mean. So this is pretty much what you need to do. And again, for the z-test and the t-test, I will post our document where you will find, so our document, you need to find that with the z-test and the t-test, that PDF file. From there you can calculate these two. I'm also going to post a chapter 8 group assignment number 8. First few problems you should be able to do after you see this lecture. All right.